So last time I think we were talking about profit function, right, where we said profit is denoted by the letter, Greek letter pi, and we said that is equal to total revenue minus total cost. Now we are going to talk specifically about total cost, and although I have posted lecture note 7 for you and you have it for a couple of weeks now, but we have not covered lecture note 7 entirely yet. If you have read lecture note 7, there are parts that we have not covered, and hopefully after today's class, if you go back and read lecture note 7, the pieces will kind of fit in and it will make a little more sense to you, hopefully. Okay? So now we are talking about this cost part of business. So any business, any firm in economics, be it in the healthcare field or any other field, every firm has three major objectives. Okay? Three major objectives. One is maximization of revenue, that means earn maximum revenue possible. Okay. If revenue has to be maximized, then in some way, sorry, why am I calling this 3? Okay, maximization of revenue. If revenue has to be maximized, then in some senses it is necessary that the output or the total product must be maximized. So output maximization, which is kind of embedded in revenue maximization. If a business wants to maximize revenue, then it must maximize its output. Okay? And if a business ends up maximizing its revenue, then usually it is able to maximize its profit. So profit maximization. But even if a business is able to maximize its revenue, it may not always be able to maximize profit. Profit maximization is only possible if along with revenue maximization, you also have cost minimization. Okay. So that means there are three objectives of a firm: revenue maximization, profit maximization, and cost minimization. So if a firm tries to maximize the revenue, then in some ways it must try to maximize its output. That means it must try to produce as much as it can. And if the firm is able to produce as much as it can and hence earn as much as it can, then usually it is able to make as much profit as it can. But that is not guaranteed unless it is able to do so at the minimum possible cost. Okay? That is what it means. And this equation basically tells you the same thing, because this total revenue, like I told you, this is price of the good times, you know, the number of units that is produced, where that Y is the total product or the total output, and that total cost depends on the prices of the inputs, that is WL plus R times K. Okay? Now this individually, just this part individually, that is called the revenue function, and just this part separately, that is called the cost function. Okay? So that means we can say that this profit function or this profit equation, this is a function mathematically, this is a function of total revenue and total cost, or in other words, profit depends on total revenue and total cost, right, in very simple terms. If that function things kind of throws you off, just know that profit depends on total revenue and total cost. So to make high profit, you must either be able to pull your revenue up, or you should be able to push your cost down. That will ensure that your profit of your business will increase. But this total revenue is a function of the total output, correct? And this total cost is a function of your input price and the amount of inputs that you use, L and K, isn't it? So that means I can say that this profit is also actually a function of that total output, and it's also a function of that input use. not directly but implicitly. Do you see what I am saying? So, A is a function of B and C, B is a function of D and C is a function of E. So, A is also a function of D and E because B means D and C means E. Do you see what I am saying? So, I am just trying to say that A is a function of B and C, B is a function of D and E is a function, C is a function of E. Okay. In that case, A itself by transitivity becomes a function of that mathematically. That is all I am trying to say. Okay. You do not need to get into the intricacies of the math, but just have the concept clear that one, profit is a function of revenue and cost, revenue is a function of the output, while cost is a function of input use. So, implicitly the profit also depends on this total output and it also depends on the efficient use of inputs. Okay? Because the ultimate objective of a business is to earn profits. There is no firm owner or there is no business owner who would ever tell you that I am running a business to make loss. Every business wants to make profit. But where does that profit come from? That profit comes from revenue and from cost, and that revenue and cost come from how much output is produced and how efficiently the inputs in the business are used. Okay? Is that clear? Is that clear? Okay. Now, moving on. Last time we were talking about total cost and we said to make things simple, let us assume that this is a short run period, and in the short run any one of those two inputs can be fixed, either labor can be fixed or capital can be fixed. We assume that labor is the variable one and capital is the fixed one. So, we have variable labor but fixed capital, and why are we making this assumption?
That wasn't a joke. You said that in America, or in poorer countries, labor fluctuates more. In America, it's.
I said that usually in America you have a capital intensive method of production, which means more capital is used than the amount of labor. So, if I had long run, he has a point, do not laugh. In long run, when both variables are input, both inputs are variable in the long run, at that point in time in a country like America you would have more capital and less labor. Do you see what I am saying? It is more capital being used than labor in a country like America or any developed country, if it is long run, if both can be changed. And in a country like Ethiopia, let us say,
Will they both stay variable?
Both will be variable. When both are variable, when you can change both, then in a developed country, usually the developed country you will use more capital than labor, whereas a less developed country will use more labor than capital. But here I am making an assumption that capital is fixed and it is only labor that can be changed, irrespective of what kind of country or what business it is. Okay? And why am I making that assumption? Because if you think of any business, be it in any country, it is always easier to hire workers than to buy machines. Because no matter which country you are in, machines will always be more expensive than workers. Okay?
Because of the depreciation
Of what?
machines.
Because of depreciation and also in general, machines are costly. The absolute cost is also more and most machines have to be maintained over time. There is depreciation and maintenance is required. Okay? So, coming back, now this is short run where your capital is fixed and your labor is variable. So, we said that this total cost would be dependent on the cost of capital, right, because those are the things that we are using, plus it will be the cost of labor, right. Now, since the amount of capital is fixed, since that's a fixed amount, then that cost will also be fixed. If I am using 5 units of capital, I am spending on those 5 units no matter what. So that expenditure is not changing over time. So this part is we call the fixed cost, FC, fixed cost. So that means given this assumption, given this is true, the cost of capital is the fixed cost. Given that capital is the fixed input, the cost of capital is the fixed cost. Okay? Similarly, this can change because today I can hire 2 workers, tomorrow I can hire 3 workers. Today I have to pay the wages to 2 people, tomorrow I will have to pay the wages to 3 people. Day after I may have to pay wages to 5 people. So that cost can change over time. So that cost is called the variable cost. Okay. Similarly, given that labor is the variable input, the cost of labor is the variable cost. Okay. Now, if I had a situation, if there was interchange, if I considered labor to be fixed and capital to be variable, then that would also change. Okay. So variable cost is the cost of the variable input. In this case, labor is the variable one. Fixed cost is the cost of the fixed input. In this case, capital is the fixed one. Okay. Now, let's say, just digressing a little bit,
I just want to clarify, the fixed and constant are the same thing.
yes,
Okay.
same thing.
When you're talking about a short run and a long run, it's not, is it just different, I guess what I'm saying is, can a firm be a short run and then a long run, or it's always one or the other?
A firm can be either in short run or in long run. It cannot be in both periods at the same time.
So it's just a period of time, like looking at it from an economic standpoint, just that period of time?
Correct. It cannot be classified as 6 months. It cannot be classified on the basis of a unit of time. Like it cannot be classified as months or years or days. But from an economic standpoint, we just classify it in terms of is one input fixed or not. That's the only thing. But a firm which is in short run is in short run. If it has to go to long run, then it has to make both its inputs variable. And that's a more realistic situation. The long run is the more realistic one. But here we are just capturing the simple side of it. Anyways, digressing a little bit, if I have an equation, 100 is equal to 50 plus 50. Okay, I have a mathematical equation. You don't have to take this down. Now, if I say I am dividing 100 by 2, if I divide the left hand side of the equation by 2, then I should divide the terms on the right hand side by 2 also, right? Then I should divide this by 2 and I should divide that by 2. That will balance out the equation again. Correct? You understand this concept in math? So that means whatever I do, if I do a division or a multiplication on one side of the equation, I should do the same on the other side of the equation to balance out the left hand side and right hand side of the equation. Correct? So let's say I am dividing the left hand side of this equation by total output or total product, which is that capital Y. Okay? Let's say. So I am dividing the total cost by Y, where please remember that that Y is my total output or total product, the same thing, the TP. In your lecture note, that Y is given as capital Q. It's the same thing. Keep a note to yourself. In your notes, in your lecture note, that is capital Q. Okay, because that note is from my microeconomics class. In their textbook, it is given as capital Q. Okay, but in some of the later notes that I give you in your healthcare economics, it is given as Y. So I wanted to use Y for you guys. But it's the same thing, Y or Q. So then I should also divide the right hand side by those terms. So I should divide the capital cost by Y or the fixed cost by Y, and I should divide the labor cost by Y. Right? So that means what am I doing? This is basically, I am producing 100 shirts. This is like 100 units. And I am saying my total cost of producing those 100 shirts is 1000. So I am dividing 1000 divided by 100. So basically I am finding the cost of one shirt. And what is that? That is the average. It is the average cost. Do you agree? All of you, if I say the total score of this class is 1000, what is the average score? You will take the total score, that is 1000, divided by the number of students, which is 23 in your class. That will give you the average score or the mean score, correct? So this is basically the average total cost, ATC, average total cost. And by the same logic, since I am dividing it by the number of units produced, this should be the average fixed cost or the average cost of capital, and this must be the average variable cost or the average cost of labor. Agreed? Please remember this. This is an important thing for you to remember. That average total cost of a business is the average fixed cost plus the average variable cost. Now, in this equation, if I have two things given to you, you should be able to get to the third one. It's an equation in three unknowns. If two are given to you, the third one you will be able to get. That means average fixed is ATC minus AVC, and AVC is ATC minus AFC. That will hold in this equation, right, by reorganizing. Now, a little bit, moving away a little bit from this, and we will come back again here. Now, apart from average and total, the other concept that we are most interested in is the marginal, because we were also talking, when we talked about productivity, we talked about total product, we talked about average product, and we talked about marginal product. When we talked about revenue, we talked about total revenue, we talked about average revenue, and we talked about marginal revenue. So, similarly here we must talk about marginal cost. Okay. Same definition, marginal cost is the change in total cost due to change in 1 unit of output. That means, if I have to produce 1 additional shirt, then by how much does my total cost change due to the production of that extra shirt? Do you see what I am saying? So, let us say today I am producing 100 shirts, and my cost of producing, my total cost of producing that 100 shirt is 1000. Tomorrow, if I produce 1 extra shirt, as in if I produce 11 shirts, 101 shirts, then obviously I will need more money because I am producing extra. So, my total cost will definitely be more, but that is not captured here. What is captured here is by how much would that total cost change due to that production of that 101st shirt, that extra shirt. Okay? Do you understand? So, total cost will always increase. If I produce more, total cost will always increase. If I produce 11 shirts instead of 10, it will always cost me more to produce 11 than 10. But here, when I am capturing marginal cost, I am trying to ask myself the question is, how much is my total cost rising due to the production of that 11th one? Okay, exactly the same concept as your marginal utility or marginal benefit or marginal revenue. Any marginal concept means another one. How much will you satisfy because of that extra donut in your test? Right, that confused many of you, another donut. So, okay, so 1 additional. Now, so where am I getting? So, that means if there is any addition, so let us say I am producing the 11th shirt, okay, I was producing 10, okay, let us say I was producing 10 shirts and I was taking $100 to produce those 10 total. So, this was my Y, that is how much I was producing. Now, I produce 11 shirts and let us say this is 120. Okay. That means, for the 11th shirt, my total cost has increased by $20, isn't it? Just for the 11th one, my total cost has increased by $20. Now I am still in the short run, right? I am still in short run. My capital is fixed. My labor is the variable one. So I can only change labor. I cannot change capital. So that means this 20 that I have got, this additional 20 that I have got, this cannot come from capital, right? I have definitely not used more machines to produce that 11th one. Why? Because I cannot change the number of machines. I have to use the same number of machines to produce 11 as I have used for producing the first 10. By assumption, my number of machines is fixed. So this entire increase of $20 must have come from labor. Do you agree? All of you, are you clear about this? This is an important thing that you must understand.
Yeah,
Are you clear?
yeah,
Okay. So that means the $20 that has increased, it cannot be on account of capital in this case because I have assumed that I cannot change the amount of capital. So whatever increase must show up, it must be because of labor. So can I say that this increase in total cost, I agree that this is a change in total cost, but this change in total cost has come from labor, or it is on account of variable cost and not on account of fixed cost, because fixed cost is fixed, right? So that cannot change. Do you see what I am saying? So this is a change in total cost, and this change in total cost must be change in fixed cost plus change in variable cost, because total cost is fixed cost plus variable cost, right? But here, since I cannot change capital, this change in fixed cost will be equal to 0. There is no change. I cannot change it. So whatever change must take place, it must be through the variable cost. So that must be equal to the 20. Now that variable cost is coming from labor, right? So that means whatever that variable cost is, that must be changing because of the characteristics of labor, right? So if variable cost has to increase or decrease or stay unchanged, that must only depend on how labor functions in the business, or what is the characteristic of labor in that business. And so far you have learnt about one single characteristic of labor. What is that characteristic? Can you tell me? How does labor behave in a business? The productivity of labor diminishes over time. That is the only characteristic that you have learnt so far, right? So labor has diminishing productivity, the law of diminishing marginal productivity. That means in a business, when you hire labor, it is initially extremely productive, but there will be a point where that productivity drops, and then the labor starts becoming less and less and less productive, correct? So now think from the flip side of things. If I am a business owner and I hire a worker, and then I hired the second one, then I hired the third one, initially it is extremely beneficial for me to hire those workers because they are all productive workers, correct? But then after a point, those workers start becoming less and less and less productive. So can you understand that if I have to pay the same wages W, because remember last time I told you W and R are fixed. So if I have to pay the same wages W to my first set of workers who are extremely productive, and then the same W to the next set of workers who are less productive, then can you understand that over time it is getting costlier for me to hire those workers? How many of you understand that concept, and how many want me to repeat? Okay. So I am a business owner. My W, or the wages that I have to pay to the workers, is fixed. I cannot discriminate between workers, right? I have to pay the same wages to my factory workers. But I don't know anything about their productivity, but given that I cannot change the number of machines in my factory, there will be a situation where the first set of workers that come in are going to be highly productive, but then there will be a point where their productivity peaks. Remember that marginal product curve, the peak, and then after that point the marginal product of the next set of workers is going to start diminishing. So from my cost perspective, when I bring in the first set of workers who are extremely productive, at that point they churn out maximum output for me with maximum productivity. So, it is extremely good for me, or it is cost effective for me to hire those workers. But as I start bringing in less and less and less productive workers, or in other words, when the diminishing productivity sets in, it is effectively becoming costlier for me to hire those workers, because I am having to pay the same wages to these less productive or unproductive workers. So, it is a costly affair for me, right? Do you agree? So, that means, can I say that this variable cost, this cost of labor over time, as I produce more and more and more output, this variable cost is bound to increase over time? So, that means this increase in variable cost over time, can I say that this increase is caused by, this increase in variable cost is caused by diminishing MPL? That is the reason that this happens. If labor had been extremely productive over time, then this would not have happened. The fact that labor becomes less productive, the fact that the MP curve is, inverted U shape, that is the reason that my variable cost rises over time, isn't it? Now, one common mistake that you will commit, and one common mistake and one common confusion that you will have while studying, is you will think that, oh, variable cost is the cost of labor, so the cost of labor is W times L, so definitely this is because of W. Please keep a note to yourself and put as many stars as you want that we are not talking about an increase in W here. We are not talking about an increase in the dollar bills, the green paper that goes out of the pocket of the business owner, but we are talking about effectively what it means for him. I would want to pay the same wage and get the same productivity from the person, but if I have to pay the same dollar amount and yet get less productivity, that is a, that is a harm for me. Okay, that's an increase in my cost. So, that variable cost is increasing because I am having to hire less productive workers over time, and I am having to hire less productive workers over time because I cannot do anything to my capital stock. So, if I keep bringing in more and more workers, their productivity is bound to decrease over time because they are being underutilized. They do not have enough machines to work with. Is that clear? So, one is kind of interconnected with the other. So, then now we have got one part sorted out. That means the variable cost increases over time, right? Variable cost is increasing over time. So, what should happen to the average variable cost? If variable cost is increasing as production is increasing, so that means here this is the average variable cost, right? So, that means as y is increasing, VC is also increasing. So, numerator is increasing, denominator is also increasing. What do you likely expect to see in the fraction? Just look at the numerical example and try to say. For one increase in shirts, you are having $20 increase in the cost. So, what do you expect to see? Usually, the numerator increase will be higher than that is anecdotal, but the numerator increase will usually be bigger than the denominator increase, which will take that entire thing up, right? So, usually due to an increase in VC, as you produce more and more and more of Y, usually VC by Y will increase, or in other words, the average variable cost will also increase. Okay? Do you want me to repeat that part? Do you understand what I am saying? So, I am saying that over time, as Y increases, the variable cost also increases. So, if I have to find out what happens to average variable cost, then I have to look at that fraction VC divided by Y. Now, in that fraction, the denominator is increasing over time, and that numerator is also increasing over time. So, what happens to the value of the fraction will depend on the relative increase of the numerator versus the denominator. right? Which one increases more than the other? Anecdotally, we find that usually the numerator increase is usually greater than the denominator increase. So, that means as we produce more and more, as y increases, AVC also increases. Can you please write that down? As more output is produced, within parenthesis, total output increases. As more output is produced, within parenthesis, total output increases. Average variable cost increases due to diminishing marginal productivity of labor. Due to diminishing marginal productivity of labor. Okay. So, that is about this part. So, we know that as y increases, this part increases, right? AVC increases. Let us clear all that out from here. Now, we still have another part which is the AFC. So, that is the fixed cost, that is the cost of capital divided by y. Now, if I am producing more and more output, if I am producing more y, can you tell me what happens to this numerator, just the FC? If I produce more y, what happens to just the numerator, FC? Stays the same. Will all of you agree? Because FC is just the cost of capital, right? So, if I produce more and more and more output, I cannot do anything to the capital. My number of machines is still the same. So, my fixed cost must be the same, correct? But what happens to this fraction? As y increases, what happens to that fraction? That should become smaller because numerator is fixed, but denominator is increasing. So, only if the denominator increases, then as a fraction, the value of the fraction must go down. So, that means, can you now write that down? The same thing as you wrote for average variable cost, can you write that as more output is produced, within parenthesis, total output increases, AFC decreases. Is everyone okay with that? So, that means we are saying that as y increases, you have an increase in the AVC, but you have a decrease in the AFC. Agreed?
How can it decrease if it's a fixed?
Remember, the numerator is only fixed. This y is changing, right? So, this is fixed. If you have a fixed numerator, but the denominator is increasing, then as a fraction, the value of the fraction will decrease. Fixed cost is fixed, but average fixed cost is not fixed.
So wouldn't it be your fixed cost divided by your output, wouldn't it be called a marginal cost or something like that?
No, marginal is about the change. Marginal is not about the total. This is total fixed cost. Total fixed cost plus total variable cost. If I divide that by y, I get the average. Okay? So, fixed cost will fall over time, variable cost will rise over time. Now, like I told you that this rise in variable cost, that is triggered by the diminishing marginal productivity of labor, right? That is causing that. Hence, this is known as this increase in variable cost over time or with an increase in output, that is also called the diminishing returns effect. And this is given in your lecture note 7.
Which is also the diminishing marginal, no.
Diminishing marginal productivity is just about productivity, but this fact that AVC increases due to diminishing marginal productivity, that is called diminishing returns effect. So diminishing returns effect is just a phenomena about average variable cost increasing over time. But what is the cause of that effect? The cause of that effect is diminishing marginal productivity. Okay. Similarly, this decrease in AFC, this also has a special name. Now please see that this is as if, you know, you had a fixed pie, right? You bought a pie and you are just bringing in more and more people to share that pie, isn't it? So you have one pie, you have one person to eat that pie, that one person can eat that entire pie. You bring in another person, they have to share it half and half, or 40-60, whatever. Third person, each person gets a smaller share. You bring in more and more and more people, then each person ends up getting a smaller share of the pie. So what is happening? That pie is getting shared or is getting spread out between more and more people. So it is the same thing, the same concept here. The fixed cost is like the pie, and Y is you are dividing that fixed cost between the number of shirts that you are producing, and then the number of shirts is rising over time. So your cost of capital is getting spread out or shared over more production. So hence this part is called the spreading out effect. Please note that these two effects can never be in the same direction. Yes? The AFC going down, only that part. Only the AFC falling, the decrease in AFC as Y increases, that part is called the spreading out effect. And the increase in AVC as Y increases, that is called the diminishing returns effect. Okay? And these two effects can never be in the same direction. They will always be in opposite directions. That means while the spreading out effect is causing an increase, the diminishing returns effect is causing a decrease. Okay, they can never be in the same direction. Now, so now I have this ATC, the average total cost. You can see that the average total cost depends on two things, the AFC and the AVC. And as you produce more output, one goes in one direction, the other goes in the other direction. So that means I don't have a certain result for ATC as Y increases. As output increases, I cannot say for sure what would happen to ATC. Why? Because AFC will try to pull the ATC down, whereas the AVC will try to pull the ATC up. So the total depends on two things, and those two things react differently to Y. As you increase Y, your AFC wants to come down and your AVC wants to go up. So the spreading out effect creates a downward pull on ATC, whereas the diminishing returns effect creates an upward push on the ATC, right? So that means there is a tug of war going on there. So how can you draw the picture? If I had to draw a picture for the ATC, I cannot say that the ATC is upward sloping, because it would be upward sloping only if I consider that part. And similarly, I cannot say that the ATC is downward sloping, because it would be downward sloping only if I considered this part. So now it has to be a combination of the two. It has to be downward sloping for some parts, and it has to be upward sloping for some other parts, depending on which part is stronger, which pull is stronger, correct? So then if I try to draw this, and I am measuring Y, the ATC should look like this. For some parts it should be coming down, for other parts it should be going up. Okay. It looks like a U shape. So this is the part where the ATC is falling. That is the part where the ATC is rising. This is the downward sloping part, that's the upward sloping part. So the downward sloping part must be the one where The AFC is trying to pull it down, isn't it? Because it is the AFC that creates that downward pull. So if the downward pull is the one that has happened actually, then this is the one that must be the stronger pull, correct? So can I say that in this zone 1, the spreading out effect is stronger? Or in other words, the fall in AFC is bigger than the rise in AVC? The fall in AFC is stronger than the rise in AVC. Similarly, in zone 2, the ATC is rising, and that rise must be caused by something which is pulling it up. That's why it is rising. That must be the stronger pull. So that means here the pull of AVC is stronger. And what is that pull of AVC? It's the diminishing returns effect. So there it must be the diminishing returns effect that is stronger. Okay.
So it's the opposite of the productivity model.
Correct. Opposite of the,
And then eventually drop it off.
correct. Absolutely. Okay. Now, follow up to your question, why does this not look like why is this the picture instead of the picture being like that? Because there could be, I could say that, okay, why is this is the place where my diminishing returns effect is stronger, that's why the ATC is going up, and this is the place where my spreading out effect is stronger, that's why the ATC is going down. Possible, right? Hmm?
They hired too many workers, so total cost went up. They got rid of a couple, so the cost went down.
Correct, very good. Okay, because this is not possible, because note, what am I measuring here? I am measuring Y, that is I am measuring output. That means in this zone, my outputs are all lower, isn't it? Whereas in that zone, my outputs are all higher. And you know that it is only at higher levels of output that diminishing marginal productivity of labor sets in. When I am producing 1 shirt, 2 shirts, 3 shirts, I have 5 machines and I am hiring 1 or 2 or 3 workers. That time I am hiring the more productive workers. At initial stages of production, I am bringing the more productive workers. That means if I have the, below this panel, if I am trying to plot the productivity, which I plotted earlier, if I am plotting marginal productivity of labor here, this is the part where my marginal productivity rises, and that is the part where my marginal productivity goes down. In the initial units of hiring, it is more productive workers, and in the later units of hiring, it is the less productive workers. And in the initial units of hiring, the output is less, and in the later stages of hiring, it is the output high. Okay. So there is relation between all those diagrams. They are all interconnected. So just drawing that diagram here. Now let's say on y-axis, instead of just measuring the average total cost, I am also measuring average fixed cost and average variable cost. They are all 3 on the y-axis. So if I draw the ATC curve will look like that, the U shape that I have put there, the same ATC curve. Now in this same diagram, if I want to draw the fixed cost, what will the fixed cost look like? If I want to draw, the average fixed cost, what will that curve look like? So as you produce more and more output, what happens to average fixed cost? You just wrote it down. It goes down. right? So what should happen to, so what should that average fixed cost look like in this diagram? Downward sloping, correct? So average fixed cost should look like don't draw it yet, let me draw it, then draw it. I'm trying to show something. So it will be like that, isn't it? Average fixed cost, downward sloping, because of the spreading out effect. As you produce more output, that is getting spread out, the fixed cost is getting spread out, so the average fixed cost is falling. Now can you see that deliberately I have drawn the two curves in such a way that the distance between those two curves is kind of tapering off? Can you see that? That the distance between these two curves is tapering off. That means what am I doing? I had this equation, my ATC was AFC plus AVC, correct? What is that distance between those two curves? The distance between those two curves is ATC minus AFC, which is equal to AVC by that equation, isn't it? The distance between these two is the distance between ATC and AFC, isn't it? And by that equation, that is AVC, correct? So that means if I shade out this portion, what is that? That is average variable cost. And what did we just see about average variable cost? We just saw about average variable cost that as you produce more and more output, the average variable cost increases. That is exactly what is happening. As you produce more and more and more output, that difference is increasing. Or in other words, the average variable cost is increasing. You don't have to draw the blue diagram, the one that I am drawing, but I just want to show you something. You don't have to draw the blue one. If I only wanted to plot AVC, on the y-axis as y increases, then AVC would look like that, isn't it? As you produce more output, your average variable cost increases because you have a diminishing marginal productivity of labor. So you are bringing in less and less and less productive workers. So your cost of hiring is effectively increasing. And that is exactly what is given in your lecture note. In your lecture note, if you see the AVC curve, that AVC curve will be upward sloping. But another way of capturing, this diagram is probably not there in your lecture note, but one way of capturing that AVC, instead of drawing that curve, I can say it's the distance between these two curves, because that is what I get mathematically. So let's say if my production is anything, 5 units, then at this 5 units, this is my average fixed cost, and that is my average total cost. So that is ATC for 5, and that is AFC for 5, correct? So what is the difference? ATC minus AFC, so that must be AVC, and that is the distance between these two curves diagrammatically. Because producers are rational, so that means a producer will not want to be in a place where his cost is going up, because remember what we started with, that the objective of the producer is to minimize the cost minimization, isn't it? So that means the ideal place for a producer is to be at the minimum point of that ATC, correct? Do you agree? That is his minimum cost point, whereas ATC is the lowest. Because at the end of the day, he is not worried about what is my fixed cost and what is my variable cost. He cares about his total. He cares about his average total cost. Whether that is coming from labor or that is coming from capital, that is immaterial to the producer. So if a producer has to satisfy his objective of cost minimization, he has to produce at minimum cost. And this output, this particular output, is his minimum cost output. coming back, so that means this is the minimum cost point. Right? That's the minimum point of the ATC, the very bottom of that U, and that will be one unique point, although my diagram may not look like that, but it will be one sharp point like that. And the output corresponding to that minimum cost is Y star. So that means when I said profit maximization and cost minimization, to attain the objective of cost minimization, this particular firm must produce this Y star amount of output, and if it produces that Y star amount of output, it is going to have the minimum cost of production, which is given by this. Okay? This or that level. That's the minimum cost. Okay? So that means the producer will want to be at Y star. In other words, that is the optimal amount of production for this producer. So in theory, the ATC may be going down or it may be going up, and that could be due to fixed cost or variable cost, but every producer ultimately wants to be at his minimum cost, because that is the optimality point for the producer. Okay? Now just one more question. Okay. Just one more thing before I end today's class. That is, so we have spoken about variable cost, fixed cost and total cost, but we were talking about that marginal cost right there. Where does that marginal cost fit into this picture? Okay, we had that marginal cost, which was change in total cost for every change in output. Okay. What do you think happens to marginal cost over time? Remember, in that example, that $20 was the marginal cost, isn't it? And we said that $20 was coming from labor cost because capital was the fixed input here. So that means, what is that marginal cost? What is that $20? It's the change in the variable cost actually, isn't it? In this example, because capital is fixed. So that marginal cost, don't you think it should behave in the same way as the variable cost? Because effectively it's the variable cost. That $20 is because the change in the cost of labor, because there is no change in the cost of capital. Do you understand my point? So that $20 is being caused by more workers, and hence it is actually the variable cost that is changing, although we are calling it change in total cost, but this change is being brought about by the change in VC, because you have written somewhere that change in FC was equal to 0. Isn't it? You have written, if you turn back the pages, you will see that your change in FC is equal to 0. So it's effectively this change in TC is equal to your change in VC. So this MC must behave in the same way as your variable cost. So what should be the shape of your MC? It should be the same shape as your AVC. In other words, your MC must be upward rising just like that. Isn't it? MC will be upward rising, and if it is upward rising, no matter where, it could be here, it could be there, but it will cut the ATC at some point. It will go through the ATC, since the ATC is U-shaped, it will go through, it will intersect the ATC at some point. Now the objective of the producer would be to produce at that point, or to make sure that that MC intersects the ATC at exactly its minimum point. Why? Because MC is rising because of what? MC is rising because of diminishing productivity of workers. That's why MC is rising. To bring in every additional worker, it is becoming more expensive for me because those workers are less productive workers. So as a producer, as a rational producer, I would want to hire only those many workers, and I would want to produce only those many shirts for which my MC is exactly equal to my minimum average total cost. I will not want to be in that zone where my MC is rising even further, which means I am bringing in even more and more unproductive workers into the business, like he pointed out. That why would a producer want to do that? That means a producer will never want an MC which looks like that. which is in that zone of the ATC. He will always want the MC to be in this side, and he would want to get to a point where the MC is passing through that minimum cost point. That means that his MP is at the peak, because see that MP is the one which corresponds with the minimum point of the ATC. So, minimum point of ATC means the marginal productivity of the worker is at the peak. So, that means if I am producing this Y star, effectively I am also hiring the exact number of workers who will give me maximum productivity, L star. And at that point, if these two are true, then my MC will also go through that point. Okay? So, you can write this sentence down that MC intersects the ATC, MC intersects the ATC at the optimal point of production, that is Y star, at optimal point of production, that is Y star, MC passes through ATC at its minimum most point. At the optimal point of production Y star, MC passes through ATC at its minimum most point. So, that is where we had started. We said the objective of the producer is to minimize the cost, and the objective of the producer is to maximize the revenue, and we started by saying that effectively profit depends on total revenue minus total cost, but this total revenue depends on Y, and this total cost depends on L and K, but we assumed the K to be constant. So, that means this profit depends on Y, and this profit depends on the efficient use of L. So, after all these things, where we have landed is that this profit will be maximized or optimized only if the producer is able to produce the optimal Y, and he is able to use this labor in the most effective way. So, profit maximization depends on output optimization, and it depends on the optimal use of the input. That is what we are trying to say. For every business, I cannot do random things. I have to produce the amount of output using the input most efficiently, and that efficient use of input will be meaning stopping at the point where the productivity of the worker is the maximum.